Okay, so now I want to start to actually look at the graphs of some of these trig functions, and I want to start with just the sine. So let's take a look at the graph of y equals the sine of x. And so here the independent variable here is x, and if I knew x, I just compute the sine, and that's going to be the y. So I want to look at the graph of this like we graphed all sorts of other functions. Well, what do I do here? Well, we might want to start by just sort of looking at a table of values and plotting those points. So you can put a table of values up here. You can see them here. And so this is a table we just made. So it's got 0, pi over 6, pi over 4, pi over 3, pi over 2, and so forth. And let's start graphing and see what this thing looks like. Now what I'm going to do is we're graphing this, by the way, in radians. So let me put this value right here. I'll make this 2 pi. So that's the angle that goes once around. It's the same thing as 0. This would be pi. This is pi over 2. This is 3 pi over 2. And let's see how we make out. Okay, so if we plot some points, what is the sine of 0? If I plug in 0, how high do I go? If I plug in 0, I see I just get 0. So in fact, this is just 0. When I plug in pi over 2, you can see from the chart, we just have 1. So we go up a height of 1. In fact, I should probably label 1 up here. Here's 1. And then here's minus 1. So we go all the way up to 1. Now what about at pi? Well, if you think about what's happening at pi, that's pi, 180. So what's the reference angle? The reference angle is actually 0, right? It's the angle that's left over. So it's 0, and so what is the sine of 0? We know it's 0. So in fact, at pi, I'm back to 0 again. Okay, what about 3 pi over 2? Well, 3 pi over 2 comes sort of way down here. So we get something down here. And so, well, it's sort of hard to say what the reference angle would be. I guess the reference angle might be like, pi over 2. And if it's pi over 2, and what's the sign of the sine? Is it positive or negative? All students take calculus. So I see that the sign is positive here, but negative down here. So in fact, this is going to be negative value. But what is it at pi over 2? It's 1, so it's going to be negative that, so it's going to be negative 1. So here I color negative 1. And what about 2 pi? Well, 2 pi is the same thing as 0. And we know that the sign there is 0. And what if I keep going? Well, see, if I keep going, now I'm just going to repeat what I've already seen. Because, for example, when I get up to here, that's the same thing as pi over 2. So now once I start going around again, I'm going to start spinning. I'm going to see the exact same thing. So in fact, this is just going to repeat this picture. So let's connect the points. And what I see is a function that looks like that. And if I were to keep going, I would see the exact same picture, because now I'm spun around once. The sine function has no memory. So it just thinks that I'm seeing this, and then it goes to here, and so on. If I were to go negative angles, this graph would continue. And so I get a sine function. And a sine function has this really pretty graph. Mine's not that great, but this is much better. You can really see it. It has this beautiful wavy kind of thing. And so this is what the sine function looks like, so our standard sine function. There's some basic little language here. Let me tell you about the language. The maximum minimum values, by the way, you'll notice that they actually occur at 1 and minus 1. That height is called the amplitude. So the amplitude is just the absolute value of sort of the height, which in this case is just 1. This picture just repeats, and you can see it even here. I just take this picture and it just repeats. Take that picture right here. There's a complete cycle. And then it just repeats again, and it repeats again. This is called the period. So the period is the length of time it takes to sort of repeat. In this case, this would be 2 pi. So the period of this is 2 pi. And you could also ask, well, where are the location of the high points? Well, the high points, those sort of top points here, those maxes, occur where? Well, it occurs at pi over 2, And then here, and where's this point? Well, if you think about it, this is 3 pi over 2, this is 4 pi over 2, this is 5 pi over 2. So you see that what's happening is the maxes are going to be at any odd multiple of pi over 2. Pi over 2, 5 pi over 2, 7 pi over 2, even negative pi over 2. We're going to have max over. Okay. What about the mins? Where are the mins? Well, the mins, they occur sort of here. So what are those? Those are going to be what kind of multiples? Well, let's be careful now. So here we have pi over 2, and then here's this 5 pi over 2, and so this is 3 pi over 2. So the mins occur where? Well, the mins occur if you take 3 pi over 2, and then you just shift them over. So how far do you shift? Well, you shift it by any multiple of pi. So you take this, any multiple of 2 pi. So take that point, and now shift it a multiple of 2 pi, you get to here. Just like here, the maxes occur, you take pi over 2, and you shift any multiple of 2 pi. Right? Take this point, add 2 pi, you get to here. Add 2 pi again, you get another max. Subtract 2 pi, you get here. And the mins occur sort of over here. So you can find the mins and maxes pretty easily by just taking one of the min or maxes and then shifting it over a multiple of 2 pi. That's all there is to it. So that's how you find the max, that's how you find the mins. Where are the zeros, by the way? Where does this thing cross the zeros? Well, 0, pi, 2 pi, 3 pi, 4 pi, so forth. So the zeros are going to be any multiple of pi, right? 0 pi, 1 pi, 2 pi, 3 pi, negative pi, and so forth. You can see negative pi at 0 right there. So the zeros are easy to see. Those are the multiples of pi. The high points are exactly pi over 2 plus or minus any multiple of 2 pi. So here, here, so forth. And the low points happen at 3 pi over 2 plus or minus any multiple of 2 pi. So boom, 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 and so forth. What about cosine? Well, cosine you can graph the exact same way. And if we make a chart, we'll see what the cosine function looks like. And we'll see it's actually very similar to what we got with sine. So again, we start here. Here's 2 pi. That makes half of this pi. That's 180 degrees, by the way. Pi over 2, 3 pi over 2, and so on. What happens? What is cosine of 0? Well, cosine of 0 is 1. We saw that before. That's one of the standard points we should know. So we go up to 1. But cosine of pi over 2 is 0. So this is now 0. What about cosine of pi? Well, cosine of pi has a reference angle of 0, but it's going to be negative there. So in fact, we're at negative 1. Instead of 1, we're at negative 1. And at 3 pi over 2, we're 0. And at pi over 2, it's the same thing as at 2 pi, it's the same thing as 0, so it's just 1. So let's graph this. What we see is a similar type of function. And so on. It sort of just goes wavy again, just like before, wavy. In fact, it's the exact same function, except it's just been shifted a little teeny bit. It looks like this now. See the difference with that? Here's sine. See, sine starts at 0 and goes up. The cosine starts at 1 and goes down. But everything else is the same in terms of its shape and its curvature. But now, of course, you can tell all sorts of things. You can tell where for example, where the maxes. Well, the maxes occur where? Well, they occur at 0 and at 2 pi and at 4 pi. So all the multiples of 2 pi. So 2 pi, 0, 4 pi, minus 2 pi, and so forth. Where are the minimums? Where are the low points? Well, those low points where you get negative 1 are actually going to happen where? Well, that's going to happen at pi, and then at 3 pi, and then at 5 pi, and then at minus pi. So it's going to be all the odd multiples of pi, plus or minus, right? Pi, 3 pi, and so forth. The amplitude in this case is still 1. That was the maximum height here above is 1. And the period, notice that after you get to 2 pi, the thing just repeats again. So in fact, the period here is going to be 2 pi. Where are the zeros? Well, the zeros are now at the half marks, right? Pi over 2, 3 pi over 2. So it's any odd number pi over 2, so any odd multiple of pi over 2. So this is the general shape of the sine function, of the cosine function. This is the general shape of the sine function. You can see they're very similar. In fact, one's just the shift of the other. I can give you the sine function, cosine function. So you can see they're related in a very strong way. Anyway, what we'll start to do is start to look at more exotic graphs of these things. What happens if I put a coefficient in front of here? What happens if I put a coefficient in front of here? How does that change the general picture of these graphs? We'll take a look at those pictures, start seeing how the period can change and the amplitude can change. We'll see that next.